Welcome to Chapter 5, where we're going to talk about decimals. In many ways, you already know a lot of what we're going to do in this chapter. We're just going to add in some information about decimals, and then we're going to do all of the adding, subtracting, multiplying, dividing, and solving equations that we're used to. So let's dive right in. In 5.1, we're going to focus on the decimal point, place value, and then rounding numbers. So first, let's remind ourselves about the place values of whole numbers. So the very first place that we have is the ones place, and that represents the first whole amount, right? The ones place right here. Then if we have 10 ones, then we, instead of cramming them all into the same place value, what we do is we show, okay, once I have 10 of something, then I'm going to move one place value over, and I will indicate my ones in this column and my tens in this column. And then every time we move a place value, that's what we do. We add a place, we add a digit, and even if it's a 0, we have to indicate it, right? We have to indicate all the places that we have. And there are names for these places, right? The ones, and then we have the tens, the hundreds, the thousands, and then that process repeats of tens, hundreds, and then millions is the next, and then 10 million, 100 million, and then billion, and so on. Now, to get from one place value to the next, you multiply by 10, right? Because once there's, if you have 9 things in the ones column, and then you go to 10, then all of a sudden, we're no longer in that same ones column, we're now in the tens column. So multiplying by 10 is what will move you from one place value to the next. So 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000, and so on. Then to make your place values smaller, to go from say the hundreds to the tens, instead of multiplying by 10, right, to make them bigger, we're dividing by 10 to make them smaller. So each place value to the right is 1/10 of the place value to the left. I'll say that again because it's kind of important. Every place value to the right is 1/10 of the place value on the left. So 10 is 1/10 of 100, just like 1 is 1/10 of 1. Then what happens when you go to something smaller than 1? What happens? So what we do is we put the decimal point to the right of the ones place. So all of our whole number values go to the left, and then we have a decimal point to indicate that we have parts of a number. We don't have a whole, we have a fractional amount. And the first place value to the right is the tenths. And there is no oneths, right? Because the ones is actually kind of like the center of our place value system. So you either have 1 or you have a part of 1. And so on the left of the ones, you have the tens, and then on the right, you have the tenths. On the left of the tens, you have the hundreds, and on the right of the tenths, you have the hundredths. And then this pattern keeps repeating, so thousands, thousandths. And each place value is represented by 1 over its place value name. So in the case of tenths, whatever number you see here is the number of tenths. And so if we see something like we're going to see in the next example here, this first one this number, because there's nothing in the ones place here, we're going to read the decimal point here. So this is going to be where our whole numbers stop, and then everything to the right of this is going to be parts of a whole. So in this case, the first place is the tenths, so this represents 4 tenths. Here the 4, it's not in the tenths place, it's in the hundredths place. So this represents 4 hundredths. And then we just keep going, listing our place values, the tenths, the hundredths, then the thousandths. So this is 4 thousandths. Now, what if there's a value on the left of the decimal point? Then, no problem. That's the whole number. That's the whole amount. And then what's on the right is the decimal amount, the fractional amount, really. So in this case, if we look at this number, which we might say 5.4, but its actual name is 5, because that's how many whole parts there are, and is the name we use to represent where the decimal point is. And then we list the number and then its place value. So 4 tenths. So let's do the next couple. 5.04 is how you might hear people say that, but its actual name is 5, and 4 is the number, right? I see the number 4 here, but what place value is the 4 in? It's in the hundredths. Hundredths. And then in that same vein, this is 5 and 4 thousandths. All right, so what we can do then is, if we know the place value, we can write decimal numbers as fractions. So let's have a look. So for A, it's 0.004. But let's read this as a name. Its name is 4 thousandths. And so what we can do is we can just translate it, and we can say, we'll take the number and we'll put it over its place value, which happens to be the thousandths place. Now, if we were going to submit this as an answer, we might want to reduce. But what we want to do is we want to show the direct connection between decimals and fractions, that fractions are division waiting to happen, and when you do that division, you can end up with a decimal. So let's look at the next one here. 3.64, but really we should call this 3 and 64 hundredths. So then we'll write it in mixed number notation. And so it's 3 and 64 hundredths. And let's do the same thing for C. 25.4936 is how you might hear it. But really, we want to call this 25 and 4,936. And then what place value is this last digit in? It's in the 10 thousandths place value. So that's how you can write decimal numbers as either fractions or mixed numbers. And of course, mixed numbers are just fractions with their whole amount clearly identified. And so that makes a lot of sense that they'd be connected to decimals in that way. Okay, so let's talk about rounding. You already know how to round when it comes to whole numbers. Let's look at a number like 33. Round 33, so round 33 to the nearest, and then they'll always tell us what place value to the nearest, let's say, tens. So 33 rounded to the nearest 10. So what we do is we don't actually focus on the place value that we're interested in rounding to, but we look to the right. So if we're supposed to round to the tens, then what I do is I actually look to the right and I say, is that a small number or a big number? Is it 0 through 4 or is it 5 through 9? If it's 0 through 4, like it is, then I can round this down to a 0, because 33 is closer to 30 than it is to 40. But if it was something like 37 to the nearest tens, well, I went around to the nearest 10, so I actually look at the neighbor number, which is the 7. That's a big number. 7's pretty close to 10, so that's going to round up. That's going to push this up to a 38, or excuse me, 40, because I'm rounding to the nearest 10. Now, when we're rounding numbers, let's have a look here. So here's my first number, 24 and 785 thousandths. How would I round that to the nearest whole number? Well, all I do is I go to the whole number place, which there's a 4 there. And then instead of looking at that number, I'm going to look at the neighbor number, which is a 7. That's a big number, so that'll push the 4 up to a 5. So 24.785 is closer to 25 than it is to 24. But what if I wanted to round it to the nearest tenth? Then what I do is I look at the 7, and then I go to the neighbor number, which is an 8, and that's a big number, so that's going to round the 7 up to an 8, so 24.8. And then if I want to round it to the nearest hundredth, I look at the hundredths place where there's an 8, and then I look to the right, which is my neighbor number, and that's a big number, a 5, and so that's going to round my 8 up to a 9. All right, let's skip down to this last number here, 0.545. So if I want to round 0.545 to the nearest whole, well, it looks like it's closer to 1 than it is to 0, so I'd round it up to 1, right? If I look at this 0.5, right, I want to round it to the nearest 1, so then I look at the next number to the right, which is a big number, so that's going to push the 0 up to a 1. But if I wanted to round it to the nearest tenth, then I look to the neighbor number, and that's a 4, which is small. So 54 is closer to 50 than it is to 60. So I'll round off and replace it with a 0. So in this case, I don't need to write any of the trailing zeros. So 0.5 is the same as 0.50. And I don't need to write that extra 0. So hopefully it makes sense how to round. Rounding decimals is the same as rounding whole numbers. Go to the place value that you want to round to, then look to the right to the neighbor number. If it's a big number, round up. If it's a small number, round down. So let's round this to the nearest 100. So now we're rounding to the nearest 100, not to the hundredths, which we could easily do. Let's round to the nearest 100. So 9,235.492 to the nearest 100. So 100, that's where the hundreds place is, but that's not the number that helps me. It's the neighbor number that tells me whether to round up or to round down. In this case, 3 is a small number, so I'm going to round to a 0. And so that means that this would round to 200, and then I don't need to include any extra decimal points, any extra zeros. So what I want to do is just leave it as a whole number. So I would round it to 9,200 or 9,200. Okay, so when we are working with decimals, it's important for us to be mindful that they go in order, and it's important to recognize, for instance, here, if we're going to put these in order, and let's say I'm thinking about a number line. Let's try to draw a straighter number line. And over here is 0 somewhere, so we got negatives off to this left side. And then over here is, let's say here's 9, and here's 10. That way we have plenty of room to work, because we have 9.8 is what we have. So 9.8, Well, I know that 9.8 is smaller than any number that starts with a 10. So 9.8 would be here somewhere. And then 10 would be right there. And then between 10 and 11, I'll find the other two numbers. So the question really is this number or this number the greater one? Well, here's how we determine it, is we start looking at the largest values, and we go to the right until they don't match. And as soon as one of them is a higher value, that is the higher value overall. So I'm starting out by looking at the 1 here, where they're both in the tens place. There's a 1. They both have a 0 in the ones place. They both have a 0 in the tenths place. So far, they have the same first three numbers, 1, 0.0, 1, 0.0. Then I go to the next number, 2. Compare that to 0. Which one's bigger? The 2 is bigger, so this is the bigger number. So that means that I would have my 10 and 2 thousandths here, and then I'd have 10 and 2 hundredths here. So 2 hundredths is bigger than 2 thousandths. So let's review some of the key concepts here from this first section. So let's write 754.326 in expanded form. So that would be 700 plus 50 plus 4 plus, now I would write my decimal numbers as their fractional equivalents so that I can really see what they're worth. So in this case, 3/10, so I would write 3/10 plus 2 is in my hundredths place, so that's 2 hundredths, plus 6 is in my thousandths place, so that's 6 thousandths. And so since they're in order, they represent all the digits of my original number. All right, now we're going to go kind of backwards. So we're going to go from the expanded form to the decimal form. So write 400 plus 70 plus 5 plus 1/10 plus 3 hundredths plus 7 thousandths in decimal form. So what I'll do is I'll simply write my numbers in order. So I have 475 point, and then I have 1/10, I have 3 hundredths, and I have 7 thousandths. So that is the decimal form. Now let's write 72 and 3/10 in decimal form. So 72 and 3/10. D, how many places to the right of the decimal point is the hundredths column? So the hundredths column, remember, is, this is 100th, so it is 2 places to the right. 2 places to the right of the decimal point. Which is larger, 0.03 or 0.3? So what we do is we compare digits from left to right until one is larger than the other. So they both have a 0 in their ones place, their whole number place value, so they don't have any holes. Then in the tenths place, we're comparing 0 to 3. Well, which is larger, 0 or 3? 3 is larger, so then this number is always going to be larger no matter what comes in the subsequent place values, right? This could be, this is really kind of like a 0.30. We can always add as many zeros as we want to a number in order to help compare. So what's larger, 3 cents or 30 cents? Well, definitely 30 cents is larger. And so 0.3 is larger than 0.03. Hopefully that makes sense. That's 5.1. And if you have any questions, be in touch, and we'll see you in 5.2.